Hi guys, so today we're building a game generator using AI. I think it's a great first project. It's quick, it's easy to do, and it's fun. In the end, you get to play some games. A great way to start learning how to build LLM-based applications. So what we have here, I have two files, .env, which has my OpenAI API key, and main.py, which will have our main code. Now, what is it that we need in our application? We need a few functions. We need a function that we'll call LLMs. We need another function that is going to use that call LLM function to create game code. Now, the idea here is that we ask an LLM to generate some code using HTML, JavaScript, and CSS in a one simple file. And then we run this file and open it on our browser automatically. So the user will just give one input, which will be a snake game or zombie game or whatever game. Then the code should automatically run in our browser the game, so we can instantly start playing. So yeah, this function will create the game code. Then we need another function to create the HTML file. Then the next one should open the game, and the final one should be just play game, which is essentially a pipeline that will run all of these together. All right, so let's start by setting up our environment. So we start by creating a virtual environment. Let's call it venv. Then we're gonna need to activate it. So we use source venv bin activate, and finally we start installing stuff. So let's start with OpenAI. We're going to be using a GPT here. Now, yeah, let's start with our first function, call LLM. So we import OpenAI, and then yeah, let's get started. Let's call it call LLM. It will take a system prompt, which will provide, and it won't change. And then we have a user prompt, which will be the game name, for example. Now, the OpenAI API has some standards on how to call it and how to get the responses. So we just want this function to run all of that under the hood without the other functions having to do anything related to OpenAI stuff. So the first thing is that instead of importing OpenAI like this, we should import something from the OpenAI library, which is OpenAI with uppercase O and AI. This will allow us to instantiate an OpenAI client, which we can do here, even outside of this function. So we can say client equals to OpenAI. And once you instantiate that, we need a way to say that our OpenAI API key comes from .env. The way I like to do that is actually by using a library called .env, and then you can just say .env.load.env. And I can see we don't have .env installed, so we need to install it. .env. And there you go. Now we are working with the environment variables that are set in .env, which means the OpenAI key, OpenAI API key is set. Now, let's call it response. So that's what we're getting from the chat, right? Now, the way we do it with this version of the OpenAI API is by calling client.chat.completions.create. So we're using a chat model completion mode to create something. Now, we need to give it a few parameters. First of all is the model we're using. For this kind of use case, I think O3 Mini is a good choice because we're writing code. Second of all is the messages we are given our model. So that will include the system prompt and the user prompt. Messages should be a list of messages, and a message looks like this. It has a role and it has a content. So the first role should be assistant. Sorry, it should be system, because that's our system prompt. And the second one should be a user message, and then we're giving it the user prompt. Next, I want to enforce a JSON type message. So we can set response format equals, and then we determine the type to be a JSON object. That way we can make sure that there will be no extra messages like, hey, here's your code or something like that. In the prompt, we're going to specify that there is a field in this JSON object that will be our code. Now, this response, if we just return it like this, it's going to be a string, it's going to be a text, no matter what we do, because ChatGPT will always give us a text. What we want is the actual JSON object. The way I like to do it is using this library called AST, and then you can return ast.literalEval, which will essentially take this string object and evaluate it literally. So it will essentially turn it into a dictionary with our code inside. Now we have our first function, the call LLM one. The second one should be create game code. Now to do that, we're gonna need the call LLM function and user input again. So this time the parameter, the input, can be a game name. So given a game name, we're probably gonna have to call the LLM, and to do that we're gonna need a prompt. So it's gonna be our system prompt. Now let's turn it into a f string so we can easily pass some variables into it. Let's make it simple for now, still clear with good instructions. So let's say you are a game developer. You are given a game name. Create code for that game, all in one file, using JavaScript, HTML, and CSS. We want our game to be relatively simple, so we are sure we're not running into any issues. So let's say the game should be a simple one that can be run on the browser. And to make things even simpler, let's say should be a single page game. Now this is important. We want our response to follow a JSON schema. And then we can enforce the fact that we are using structured outputs to essentially ask for the game code. So this way we make sure that the object that we get back is going to be a dictionary with just game code in it that we can just recover straight away. Now our response will call the LLM. I think I'm missing some quotes here. Yeah, there we go. Now our response is gonna be calling the LLM, giving it our prompt and the game name. And what we'll return, now again we are following the OpenAI API schema, so we should probably in here in call LLM, instead of just getting the whole response, the OpenAI API schema actually has a lot of extra stuff that we don't need. We just need the response. So we can get it from the response here. We can change it so that we get the object straight away. So to do that from the response, we get dot choices, because often the response can have a few multiple choices and we only want the first one. Then the message, then the content, because we don't care about the role here. And then just to make sure there are no extra spaces, we can strip it to make sure it's clean. So once we get it here, we are sure we're getting the JSON object. And then here in our response, since we're getting that JSON object, all we need is the game code. All right, so now we've created our game code. Let's create the HTML file. So far what we have here is a big string of HTML code. So the next step is to put it into an HTML file. So let's call this code. And then how do we do that? So let's just always call our game game.html to make things easier. And we're always going to save it here with the rest of the code for now. So we need to open this file with on write mode. Let's call it file. And then file.write, and then we write our code. That should be it. Given an HTML code, we create this HTML file. Now we need to open this file. To do that, because the absolute path can change sometimes, I'm going to be using a library called pathlib, and we're going to be using pathlib to get our current path. So let's call it open HTML, or even better, let's call it open game. And then we're going to be using pathlib.path.resolve, and then we add game.html. That will be our path. Now the next step is to open this path. I want to open it with the browser, so I'm going to be using a library called web browser, and then here we can use web browser.open, and then we can say the file, and we give it our path. Very simple function, just does one thing, opens the file. And now to our final function, which is play game. So these won't do much. It will just be a sort of orchestrator that runs all of the functions. We need to first create game code. And to do that, we need to ask for the user input. So let's call it request. And then we use input. And then let's say, what game do you want to play? We ask for the user input. Then we use the create game code to create the user request. Then we create HTML from the game code. So we need to call it game code, and then we create HTML from it. Next, we open our game. And then finally, so we can run our file, if name equals main, we run our play game function. All right, I think this should be it. Let's check it out. Let's test it to see if this works. So in order to run it, we just run python main.py. Okay, so what game do I want to play? Let's say the snake game for now. And now it's calling the LLM, it's generating the code, it's running all of these functions. Let's wait and see how long it takes. All right, it took less than a minute, I think 30 seconds maybe. It launched this browser page, and I was already dead because I couldn't move it. Now let's press space to restart and see if it works. It does not look very good. I don't think it really works. Oh, I think, yeah, I don't know. Okay, so now we can see the pipeline works. Like, we're obviously calling the LLM, it's obviously creating some code. It is an HTML, as you can see here. It's opening the game, so everything works fine. Let me add an extra space here just for visual reasons. Now, there might be an issue either with our prompt or with the model or the way we call the LLM. I think there might be something to do with the temperature. So yeah, I'm assuming a temperature equal to 1 will give maybe some more creativity. Yeah, let's see if this helps. Yeah, so it actually helped. Now this is the game we have so far. One thing that I noticed is like it works, like I can move. Let's see if taking the little thing, yeah. So One thing you might be noticing is that it's a bit too easy because I can I can go past the walls, and it's not an issue where usually you die once you touch the walls. Let's see if touching my own tail will do something. No, apparently not. So, yep, it does, actually does. Okay, so I have game over, restart, and then I can try again. All right, so I think there might be some work that we can do on the prompt to make it a little bit better. Maybe trying different models, although I think these O3 models are good for code, but I think there should be some more examples and things like that. And obviously giving some more detail on the game might also help. So instead of just saying snake game, I could say snake game, you know, and sort of explaining the rules more or less. Maybe, you know, when I say the game should be a simple one, we could try to make it, you know, as good as you can instead of just making it simple. Yeah, let's try some more different stuff to see if it works. So it should be a simple. Let's say the game should be really good and well detailed. I want to be able to run it on the browser, and you know, let's try make it beautiful. Now if we try the same prompt, which was snake game, let's see how this affects our game. All right, so first thing we can see is that he actually made the game it looks like the first one we had, where you can't really play it. Like every time you try to work on it, you just instantly die. And then now for some reason I didn't. But yeah, the game looks a bit nicer. Like we can see, you know, there's some color scheme, score tracking. And then when you touch the walls, you actually die, and then you get your score. The buttons are a little bit nicer. So yeah, there's definitely some work to be done on the prompt. Maybe some other parameters on like temperature, maybe decreasing it or increasing. But yeah, that's it. I hope you liked it. I think it's a fun project. I think it can be expanded, and but yeah, it's definitely a good way to start. Playing around, you know, in almost basically 50 lines of code, you can build your own game generator, and it makes for a good party trick, I think. And yeah, let's keep on building.